Hello guys, in this video I want to find the graph of this parametric equation where x is equal to hyperbolic cosine t and y is equal 5 times hyperbolic sine t. So it's similar to circle. What I need to do, I need to take those both two equations and divide both sides by constants, which are 2 and 5 correspondingly, and then I'm going to raise both sides to the second power. So I'm going to obtain x over 2 squared is equal to cos t and y over 5 squared is equal to sin t. And then we need to remember really important hyperbolic trigonometry identities, that cos squared t minus sin squared t is equal to 1. So if right now I'm going to take two previous equations and subtract them, then you can see I will obtain x squared over 4 minus y squared over 25 is equal to 1. And that is actually going to be the equation of hyperbola. So right now, to sketch the parametric equation, I need to sketch the Cartesian graph first. So in other words, I want to sketch the Cartesian graph of hyperbola. For that, I need to figure out, do I have x intersection or y intersection? Because for hyperbola, remember, it's going to intersect if my hyperbola in that form, when I have x squared over something minus y squared over something is equal to something, then that means my hyperbola is going to intersect only one of the axes, either x or y. Okay, for example, if we want to find if my hyperbola is going to intersect y-axis, I need to set x to 0. And then my original equation is going to become negative y squared over 25 is equal to 1. Or in other words, y squared is equal to negative 25. And there are no real solutions. So that means that there is no points on the y-axis which are going to belong to my hyperbola. But what about x-axis? I need to say y equal to 0. And then I will have that x squared is equal to 4, so x is equal to plus minus 2. So it means my hyperbola is going to intersect my x-axis at those 2 points. And then I'm going just to sketch the graph of the hyperbola. I need to sketch it approximately. And this is going to be my Cartesian graph of my parametric graph. Finally, let's sketch the parametric graph. So for that, we need to figure out what is our bounds for t, and you can see if there is no mentioning of t, then that means that t changes from negative infinity to positive infinity. Then we need to choose either left branch, right branch, or both of them. For that, what do we need to do? We need to take sum of the t, let's take t is equal to 0, and plug in inside our parametric equation. And then you can see that x of 0 is going to be equal to 2, and y of 0 is going to be equal to 0. And again, what did we do? We used the definition of hyperbolic sine and cosine. So we know for sure that we're going to have the right branch, because if, for example, on the left branch you will choose point x is equal to negative 2, then hyperbolic cosine is always positive. So there's going to be no values for t for which hyperbolic cosine is going to be equal to the negative value of 2. So in other words, it's going to be equal to negative 2. That's why we have just a right branch, but let's figure out the direction. First, observe that our hyperbolic sine is going to be equal e to the t minus e to the negative t over 2. So when our t is going to get bigger and bigger, then sine of t is going to be always positive. So that means if I'm going to start at point 2, 0, then I'm going to go along positive y direction. So that's why we know that our direction is going to go upward, something like this. Okay, and this is going to be the parametric graph of our parametric equation. Thank you for watching, guys. If you're not subscribed to my channel, please subscribe, and have a nice day.